Okay, let's get started. How's everyone's major project going? Good? Good? Okay. Yeah, that's not too bad. Yeah, I think most of you are doing pretty okay, or pretty good. I had a look at iteration to auto marking. I think most groups have been performing really well, so I'm so proud of you. So I think majority of you has been doing okay and all pretty good. So if you haven't started iteration 3 yet, try to get started. We'll have the lecture on iteration 3 next Tuesday. So it's better that you have a look at the spec, you assign some tasks to your team members, and then you may have some questions. So you can bring that questions to the lecture next Tuesday, and then you can ask. So it's a better way of learning, rather than have no idea about iteration 3 and then go to the lecture directly. Okay, for today's lecture, we'll talk about conceptual modeling, which is part of design stage in the software development lifecycle. And then we'll have another overview of the software development lifecycle again. So we looked at that at the beginning of this term, like in week 1. And today, after we talk about design, talk about conceptual modeling, we are going to go back to that and have another look at that lifecycle, which is one of the major learning outcomes of 1531. Okay, so the first topic of today, which is conceptual modeling. We'll talk about what is conceptual modeling, and more specifically, one type of conceptual modeling, which is state diagrams. We'll talk about what is that, as well as how we can draw a state diagram. And we are going to do some activities together today, and I'm also going to give some feedback. Okay, so that's the plan for this first lecture. So the first question for you is, what is a model? Let's start with general modeling. Rather than the models in software engineering. So what is a model? Yeah.
A model is, well, it's a way of describing a particular system, usually under a sort of simplified set of conditions. Yeah, that's a very good explanation. So I'll repeat that. So a model is some way of describing a system with a simplified description of the system, right? It's easier to understand. So what I'm going to do is I'm going to find some examples on Google and ask Google what is a model. So let's just try model and then go to images. Uh-oh, this is not what we are looking for. So I'm going to add conceptual model. So you can see these are all models. So it's a way of describing a thing, right? So like in electric engineering, the conceptual model may be the circuits. Like for example, the electric circuits. So this is a very good example of modeling, like conceptual modeling. So it's not a real thing, but it models how the system works. Right, so this is a very good example of modeling. Other examples, for example, domain model. So when you are in the field of, like, for example, science, like animal science, medical science, they will also do a lot of domain modeling, like what is an animal? And there are different types of animal, and another type of animal, there are some like more specific kinds of animal. So domain modeling, for example, here we have a bank, and in a bank there are some statement, account, transactions. So this is another example of modeling. But more specifically in software engineering, what is the conceptual modeling in software engineering? Oh, these are all examples of models. Yeah, so mathematical model, this is also a very good example of modeling. So these are also conceptual modeling. It uses functions, mathematical functions to describe a thing, right? Model, yeah. So a model is a simplified representation to assist in understanding something that is more complex. So when we are using our natural language to describe, for example, a software system, For example, a to-do list. Again, we'll use that example. So you may describe this to-do list system as a user can add a new to-do item, they can delete a to-do item, they can tick a to-do list item as completed, right? So we can use of a natural language to describe this system. However, this kind of description can sometimes be really hard to understand, right? So you may meet something when you start to implement the system, right? So there are something that is missing. For example, from a to-do item to be added to another state, like the to-do item is completed, or there's maybe another state of deleted, right? So how this to-do item process from the state 1, state 2, state 3, right? So there's no such kind of process in our description. We just say a to-do list is added, to-do list is deleted or completed, right? So there are something that is missing, and when we are developing the system, there may be also bring some ambiguity, like how the system should work, right? So when we are, like, natural language, of course, can describe a system pretty well, but there should be something in between, like from our user story or user cases and our development process. There should be something in between, which is the conceptual modeling that model the system, and it's easier to communicate between the different teams on different stakeholders on the team, and everyone should be able to understand that, and we can communicate it using the conceptual model. We can make adjustment to the conceptual model and then decide on how we can implement the system. So this is the design process. So given all the requirements that we identified, like using the methodology we described in the last lecture, to the process of actually developing the system, there's something in between of the two process, which is designing the system given the requirements. And how we design how we can use an easier way to describe how we design the system, we can use some conceptual models. Okay, and this is why we need a conceptual model. Yep, and conceptual model, like in definition, it's a type of model that captures the system in conceptual way rather than in a physical way. So we didn't actually build, for example, a ship or a boat physically. We just describe, we may draw it on the paper, or we may have some system to model it, right? Rather than build the physical ship and use this physical ship to communicate with all the stakeholders. We just have a model first. And they tend to be diagrammatic or visual. So this is because natural language is sometimes can be ambiguous, it's harder to understand. But if we describe the system visually, it's easier to understand for all stakeholders. Cool. So generally, conceptual models in software can be grouped into two types. The first one is structural. So it emphasizes the static structure of the system. So for example, my current state of my laptop. So there's a screen, there's some keyboard, and the screen is attached to the keyboard. So this is the static situation of my laptop, like physically, right? So the model may have like a screen on the top, a keyboard next to it, and they are connected to each other. Right? So this is like the static structure of my laptop, of the system. So this is the first way of modeling things. Another way of modeling a system is called behavioral. Means that my laptop now is open like this. If I fold it here, it will shut down or go to sleep mode. So it changed from one state to another state. So it's another way of describing the system or my laptop. It's called behavioral. So it's just some changes in the system, and we describe how the change happening from one state to another state. Okay, and for the structural description of structural conceptual model, the examples may include the UML class diagram. Let me show you an example. UML diagram. No, this is not a good. Yeah, this is a very good example of UML diagram. So what a customer can do on, like for example, a shopping e-commerce platform. So what they can do, they can search item, they can place order, or they can obtain help. So this is what the customer can do, but there's no behavior changes. Like for example, after they search for item, then the page change from which state to another state, right? All the stock change from like 100 items to 99 items, right? So this is an example of UML. So this is one example of structural conceptual modeling. Another example is called ER diagrams. So ER diagram is used to describe a database, so a database structure. So for example, in your database, there are some users, and users may have account, they have password, they may have, for example, if it's a forum, they may have the student's class, right? So this is static information, right? So ER diagram is another example of structural conceptual modeling. So you'll learn more about this in future courses at CSE. So for example, you'll learn UML in 2521. You will learn ER diagrams in 3311, so the database course. So you are going to learn this in other CSE courses in the future. But here in 1531, we're talking more about like behavioral conceptual modeling, like how our software system change from one state to another state, which will be described as state diagrams, also state machines. Cool. So these are the types of conceptual modeling. So you can see that there are many different ways of describing a system, like conceptually designing a system. And in many cases, when we are designing a system, we may need both of them, or a couple of them. So when we are designing a software system, we will need an ER diagram to describe how our database is designed, like what kind of data is we need to store in our database, and what is the data structure. So we will need to have ER diagram. We will also need to have UML diagram to describe the objects in the system and their relationship with each other. However, we will also need to have the state diagram to describe how our system changed from one state to another state. Any questions so far? All good? Yeah, there's no coding again today, but we'll do some other activities, okay? Cool. So what are these models used for? Let's use the state diagram as an example. So what, no, let's just use general. So we'll talk more about state later. So it will predict the future states of the system. So for example, models can say, well, if you click on the button, the page will change to the next one. For example, if I click on here, the page will change to that one, right? It also, so all of this just want to express that it's a way of communication, right? So developers will understand how the system works and all the other stakeholders. And we can also change the modeling before we actually implement the system. Yeah, it's for communication. Okay, so now let's move on to state diagram. So this is our focus of this lecture and how we use designs in 1531. So state diagrams. Okay, so before we say what is a state diagram, let's have a look at this example. So this example is a state diagram for a door. A door can have two states. One is closed, one is opened, right? And it can transit from each other, right? So it can transit from closed. When you open it, it changes to another state called opened. And while it at the state of opened, you shut the door, the state changed to closed. Right. So in state diagram, there are three key elements, which are the states. For example, here, closed or opened, so the states. And another element is the transition, which we'll describe using the arrows. So these are the transitions. The third element of the state diagram is the action. So the action here are open and close. So when we are drawing a state diagram, remembering that we need to have those three elements in our state diagram, which are states, transitions, and actions. Right? If you miss any of them, it's not a complete state diagram. It's like, for example, if we miss the action here, we only have close, open, and the arrow here. So the system developer will not know like how we can transit from close to open. Right? So we need to state clearly what is the action needs to be taken to transit from state A to state B. Right? So this is a very simple example, but it's also a very good example. So there's a question from online asking, is this the kind of data flow diagram thing? I would not say it's a data flow transaction thing, but more a state transaction thing. So for example here, close or open, they are state of a door rather than the data of a door. Right? So for data of a door, maybe the size, the color, or the brand of the door, right? But here when we say state diagram, we mean the current state of the door. Yeah, question?
Should the state diagrams always be deterministic?
Sorry?
Should the state diagrams always be deterministic?
Should the state diagrams always be in the states?
Will it be deterministic? As in like each transition is like not associated with a particular probability. Each transition is like has a definite like start and end point, I guess.
Yeah, it needs to have a starting point and an end point. Otherwise, you may have for example, you have close and you have an arrow with an open action for it, but there's no end state. So when we develop a system, we have no idea like what the state needs to change to. So there should be a start and the end, and an end state.
What I mean is more like, sorry, each transition doesn't, so like a particular transition doesn't have a particular associated probability of ending in different states, but instead definitely ends at a particular state rather than like one of a number based on probability.
Did you mean like, for example, close after taking different actions can transit to different state?
Well, I mean, say there's like, you know, in that case, there's like a 50% chance that open ends up at closed. Sorry, open ends up at closed again rather than ending up at opened. Is that allowed?
Yeah, it is allowed. So, for example, you may have another arrow here starting from close to close, and the action taken here maybe you open it but shut again. But yeah. Cool. Okay, so this is an example of it. Let me see if there's any other question online. Yeah. Cool, I think. Okay, there's no other question online. So let's do another example, another activity. Let's draw a state diagram together. So when you are drawing a state diagram, what you can do is you can just have a piece of paper and a pen, and you just draw some circles, some arrows, and put some text on it. So you can do it in that way. But there are also some software, some platforms that we can use. One is called draw.io. So when you search, you can just do draw.io, and we'll start draw.io platform for you. So this is a very, very simple platform. It's quite easy to use, but it's not that powerful enough. So for example, you want to collaborate this state diagram with your team member, it may not allow you to do that. So another platform that you can use is called Lucidchart. So this one will allow your team members to collaboratively draw a state diagram together. It also has some templates, so it's more powerful. But for beginners, I would recommend just use draw.io, and that would be enough. But if you want to learn more, if you want to challenge yourself, there's another option called Lucidchart. Okay, so this is the one called Lucidchart, and the easier version is the draw.io. So let's do an activity together. So if you have a laptop with you, you can also draw together with me or draw your own version, and you can also share, and we can have some discussions. I can also provide some feedback. Okay, so let's do a state diagram for example, an e-commerce platform. Okay, so let's describe the state of an item. For example, a book in an e-commerce platform. So the state of the book can be, what the state of the book can be.
Open and close.
Sorry.
Open and close.
No. I mean, yeah, open and close. But you remember, it's an e-commerce platform. It's a digital platform. So the state of book may be in stock, or sold out. Right. So these are the states of a book, an item, a general item. So let's use book as an example, but let's just describe a general item on an e-commerce platform. So I'll start with the first one of the book, maybe in stock. Other states? Out of stock, yes. Out of stock. Anything else? Just put them here and we can organize them later.
On sale.
On sale? Yeah, that's a good one. What else? Pre-order. Pre-order. Yep. Anything else? Anything online? Let me check. What about in the shopping cart, in the cart? In shopping cart? Anything else? How to describe the state of when it's out of order and then the owner ordered more? So it's what is called? It's called what should we call that? Okay, maybe we start with those ones.
You could call it replenishing stock.
Sorry, what?
Replenishing stock.
Okay. Sorry, what?
Replenishing stock.
Is that what? Sorry, my English. Yeah, we can just use that for now. Okay, so now we have all of these states. What's the second element of a state diagram? Can you remind me? Transitions, right? So now we can have some transitions. And the third element is actions, right? So let's now draw the transitions and the actions together. So from on sale, we can do, for example, it's on sale, and the customer put that. What was pre-order? What is the state of pre-order?
Well, I mean, if the system starts in a state where you can pre-order a book, then, or pre-order anything really, then it shouldn't be able to transition back to that state. As in, pre-order should, I guess, come before any of the other states. If it starts in that state and not be reachable from a different state.
So would you recommend we have transitions with pre-order?
Well, I mean, pre-order would probably transition to in stock or out of stock.
In stock, so maybe we can have one starting from pre-order to in stock, and another transition from pre-order to out of stock.
Yeah, and also one to shopping carts.
Another one to shopping cart. Okay, so there's no single way to draw a state diagram because it's part of the design process. It's really based on how you design your system. So there's no single perfect way of drawing that, as long as it makes sense to you. But in reality, you may want to communicate the design of the state diagram with the stakeholders and ask them like whether it makes sense. So now we can think like we us as a team, as stakeholders. So we can have such kind of design together with just us. But in real life, you need to design the state diagrams with the stakeholders. Cool. Okay, so what are the actions? So for example, from pre-order to in-stock, what do you think what the action should be? Yeah.
I guess it would be like shipment of pre-orders arrive.
Shipment arrived. Okay. Shipment arrived. Okay. What about from another student here? What about the action from pre-order to in-shopping cart? Place order. Yep. Place order. That's a good one. What about from pre-order to out of stock? Any thoughts? Yeah, I'll just see if any other have it. Okay, yeah.
Maybe you should have another one which is like sold.
Sold, another state called sold.
And
Yep.
then from sold you go to out of stock. So it's like shopping cart to sold is selling, and then sold to out of stock is sold.
Sold. Okay, so sorry, what was that?
So then from shopping cart you go to sold,
Shopping cart to sold,
and then you go to out of stock.
and sold to out of stock.
Yeah.
Yep. Okay, and then we need to assign the actions here. For example, in shopping cart to sold,
Like process and pay.
maybe just paid. Yep. And from sold to out of stock.
Inventory check.
Sorry, what?
Inventory check. I guess. Check inventory.
Yeah, just check. Okay, so you can do similar things with the other states. And for example, you can also have, for example, you can have from the same state to it back here. So this is also possible sometimes. Just want to draw it better. So this is also possible sometimes. So for example, it's on sale with, for example, 20% off, and then you want to have a larger sale. So you may change that to 30% off. So this is also possible, like loop. So having a loop for one state, that is also possible. Yeah, so you may add other states, for example, from in stock to sold, replying in stock to in stock. Oops, sorry, maybe I put it here. Oopsie. Yeah, so you can do that as well. So after you draw all these arrows, you may want to restructure, reorganize how the states, how you place those states on your canvas. Okay. Yeah, cool. Yeah, so after you have this, so it's not complete. So after you complete that, what you may want to do is you may want to check back your requirement document and to double check whether this conceptual model met with the requirements, like all the requirements, the user stories, the user cases, right? And you may want to also communicate this with the stakeholders and ask like, oh, should I add another state, for example, cancel? So there may be a state like which is missing called an order is cancelled, right? So it's quite easy to modify this kind of conceptual modeling rather than if you have a very long document and you need to modify and add things. That will be a lot harder, and it's also a lot harder to identify potential problems, right? Okay, so this is an example. Before we move on, shall we do another activity? Shall we have one or two of you come here to draw a state diagram for what an example? So let's try to do the Opal card. The Opal card, like swipe that state. So when you swipe on the machine, the door opens, like the train station, the door opens. Shall we do that activity? Yeah. Let me have a look here. This is the parking one. Yeah, can we model the Opal card system as a state machine? Yeah, let's do this one. Okay, so who's brave enough and want to come here to draw a state diagram and get some feedback from the cohort? Yeah, do you want another one to join? Yeah, okay, cool, come here. Okay, so this is also a teamwork activity. I'll leave the laptop to you, and the one who is sitting here can give feedback, okay?
Okay.
Go ahead.
I want to start it?
Yeah.
Tap
This
in
is
and
a
tap
teamwork.
off.
Pardon? Tap on and tap off.
Yeah,
So
tap
what
in
I'm
and
going
tap
to
off.
do is put the map here, so if you want to discuss or ask questions from the audience, you can also do
To
that.
be exact, what are we describing the state of exactly?
The Opal card system.
As in, sorry, are we describing the state of like individual Opal cards? Are we describing the state of the system which consists of registering each Opal card's state? Are we describing...
Okay, what about we
like-
leave this question to the audience? So what kind of Opal card system we want to describe? Is it the state of a single Opal card, or the whole Opal card system?
A single one.
The single one? Yep. Okay, let's do that.
So, okay.
Oh, I love it. I love this activity.
I mean, so any single Opal card,
Just tap in and tap off.
yeah, I mean...
Start opening that.
There should be tapped on and tapped off. In terms of like internal state, there is some internal state associated with each Opal card, but that's not really relevant to this. I mean, what transitions are there then? We have like how do we... Hold
I
on.
think you could just you don't need to do that.
What?
You could just do this. Something like this.
Oh, okay,
Yeah.
right. Okay, yeah. Okay, well, I mean, there's,
Any help from the audience? Do you want to give some suggestions?
there's also,
What to do next?
Check balance.
Check balance.
Check balance.
Yeah, that's a good one.
how do I, okay, what, it would be more convenient if it didn't do that.
My recommendation is to have the states first.
Yeah, state first, right?
Yeah,
Before
and then to draw the transactions and also the actions.
the tap on tap.
Well,
Payment accepted. Payment rejected.
I mean, okay, that's sort of a separate thing though. I mean, and then payment would consist of, that would consist of changing the state of the balance of the Opal card.
Yep.
I mean, the balance of the Opal card is sort of a separate system to whether it's tapped on or off.
What if you tap on and it shows low balance? Is that another state?
Well, that's a transition from the state of tapped off to tapped off, due to insufficient balance. Although, given the fact that that does relate to the balance that's on the card, I mean, hold on.
Yep.
Yeah, I mean, the balance on the card does function differently, except, I mean, I guess, hold on. Oh, sorry. You have, I mean, it has like,
Low balance. Yeah. So there could be another two states, like after tap down. One is sufficient balance, another state is insufficient balance.
Sufficient balance. I think that's much more.
okay, sure. I'll just type sufficient balance then, okay.
Any other suggestions?
Sufficient balance. I mean, hold on.
Sorry, what?
Technically, I think this should be, hold on. There should be well, in terms of describing the steps, I think there should be tapped off with sufficient
Yes, new balance after putting in plate top. Yeah, that's a good one.
balance to tap. Well, I'm trying to describe the system in terms of like a finite state machine. It's a bit difficult given the fact that a finite state machine doesn't have internal memory. Without sufficient funds to tap on, right? Okay. Okay. You can transition from this state to this state, by topping up the card. You can also top up the card and end up still without sufficient funds, though. Whatever, I'll just leave it like that. So tapped on, that should be user taps off. User taps off can also lead to this state, though. Oh my god, this like trying to just let me just hopefully. Do you know how to make the arrow?
Different very different conceptual models. Even though both of them are correct, both of them has nothing wrong, but we may end up with very different conceptual models. But it's super okay. Like there's no one solution.
Yeah, I mean, yeah. This is non-deterministic, of course, because tapping off can lead you to multiple different states. I mean, topping up can, I guess I'll draw this in, oh, not that. Topping up can also lead back to, okay, I need like this, I need to draw like a squiggly line here.
You can just make a state
Do you want
first.
to have a look?
Pardon? You can just make a what, sorry?
You can make a state first and then just connect without like, getting arrows from here.
Yeah, but the point is it needs to connect back to itself to describe the state of like tapping.
I could do that.
Okay, yeah. Oh,
I mean, yeah, you could do that also.
Yeah. I mean, you can also top up and get back to the state of not having sufficient funds to tap on. Once you're in the state of having enough funds to tap on, actually, does this let me, I think if I go here, hopefully it's, okay, yep. And then you can tap on from there.
Okay.
Yeah, I think that should be everything, right? That doesn't technically describe the state after you tap off and then you can tap on again within like half an hour. But
Yeah, that'll be infinite.
Simple.
How about calculating how much balance is deducted based on like peak time?
based on peak time, I mean, I'm not sure that that's strictly the amount of money that is taken up by a transition sort of can't be accounted for here, because I mean the machine doesn't have internal memory, right? There's no record of the actual amount of balance at any point on here, so it doesn't necessarily change anything. The amount of money that you put onto the card or the amount of money that comes off the card.
Yeah. Okay. Great job.
Okay.
Thank you. Perfect. Great. Cool. So you can see that their focus is very. They have very specific focus on tap on, tap off, and the state of tap on and tap off. So there are also other states that mentioned by the audience, such as the font, the balance after tapping off. So this is also another state, and also like at different peak hours, the charge can also be different. So you can see that another. I'll put it properly here. So another really good thing of having conceptual modeling is it defines the scope of your system very clear. So when you are designing this kind of conceptual model, it forces you to think of the focus of your system, like the scope of your system. What kind of solution, what kind of problem you want to address with your system? Do you want to include the font, like the balance after you tap off? Do you want to include in the system considering like the peak hour payments is different?
right? So you will notice that while you are doing such kind of conceptual modeling, while you are designing that, it forces you to think of the scope of your system. So this is also another thing that you may want to discuss with the stakeholders. Again, there's no right or wrong. It's just how you design the system and what do you want to focus to solve for with your system. Okay, cool. Let's take, question.
So the transition arrows can have the same names?
The transaction actions can have same name?
So like, you see how it's like chopping it up twice?
Yes.
So they can have the same names?
Yes, they can.
And what about like the circle and the arrow? Can they both have the same name?
The circle and the arrow, can they have the same name? Normally the circles are the state, so it's a description of the state. However, the text on the transaction, so the action is a verb. So yeah. So although they are very similar, like tap on and tap on, but it's different. Like one is an action, it's a verb, but another one is a description of the state. Yep. So for example, another example we showed about the door, we had a state called opened.
Yeah.
We also had an action called open.
Yeah.
Yeah. So you see the difference? Cool. Any other questions? All good. Yeah, so here's bring the question of we use state diagrams to describe state machines, but what is a state machine? So any guess of what is a state machine? Yeah, any other hands up? What is a state machine? Just guess it. Okay.
A state machine is a machine that consists of a finite number of states.
Yes.
And has state transitions, basically. To be exact, it has a starting state and then consumes some sort of input symbols to then which determine what state transitions it can then go through.
Yeah, that's exactly the definition. So state machines are made of a finite number of states. So a good example of state machine is of a laptop or of a software system or of an Oppo card example, right? So it has different states and it can be described with those states and it has finite number of states and it can transit from one state to another state. So this is called state machine. And all the softwares are state machines. So we can always use state diagrams to describe our software systems. Other examples of state machines may be the UIs with different screens. So this is the current state of the slides. This is another state of the slide. And this is, we can also go to other states of the slides. So the UIs of different screens, this is state machines. Conversational interfaces, these are all also state machines, like can transit from different states. Cool. Okay. We'll not do that. So there's another example about the parking meter on the slide. So this is an activity that you can do after the lecture. So we won't do that activity in the lecture. So you already got the solution, but you can also have another version of it. So that's everything about conceptual modeling for this lecture. Yeah, so let's take a break for about 5 minutes and come back at 5 before 12. Yeah, 5 to 12. Okay, a quick break. Okay, welcome back. Now when we look back at the course outline or the course structure, you will notice that till now we have learned about each stage in the software engineering life cycle. We have already talked about requirement analysis, design, development, testing, development, deployment, and also maintenance. So till now you should have overall understanding of how is the life cycle of designing and developing a software system. So for each of this stage, you may notice that we didn't go into very deep. Like for example, for testing, we only talk about unit testing, but there are a lot of other types of testing. And also for requirement analysis, we also touched like very briefly like on how to do requirement engineering. And we also, again, for design, we only talk about like state diagram, but there are also a lot of other types of conceptual modeling and other kind of design, like architecture design, like UI design, UX design. There are also other types of design. So the purpose of this course is to give you an overall understanding of how software engineering works. And if you are a standalone software developer, how should you start with a client request and then get an end product? Right, so this is the purpose of the course. And if you want to get deeper understanding of any of this stage, we recommend you to take other courses at CSE. So for example, for requirement analysis, there's a course on HCI, like Human Computer Interaction Design. So that course will talk more about requirement analysis. If you are in a software engineering degree, you will have a workshop in your second year, and that workshop is particularly focused on requirement engineering. And for design, there's a course called 2521. So that course will talk more about design and a little bit about architecture, UML, and other design aspects in software engineering. For development, like your capstone projects, we'll do a lot more about development, like coding real-world software systems. And for testing, there's a new course focusing on testing as well. It's called it's a level 3 course, so I can't remember the course code. There's also a dedicated course on testing. Development, so there's a course on DevOps. So you may have learned DevOps in the development lecture. So there's a course on DevOps. It's the third year level 3 software engineering workshop. And also maintenance is also covered in that workshop as well. So the purpose of 1531 is give you an overall understanding of software engineering. While we are doing the industry review of 1531 and also the software engineering degree, we talk with the senior developers at Google, at Atlassian, and other big tech companies. And what they mentioned about learning software engineering at university is that you learn what is it at university. So you know what you should know, but if you want to get a deeper understanding, like implementing software or get in-depth understanding of software development, what they recommend is having some hobby projects or doing interns, or when they hire graduate, they even did not expect to hire graduate that know everything about software development. They expect you to learn during your work, so they will still train you. Okay, so the purpose of 1531 is show you the world of software engineering, the whole picture. But you need to continue to develop your skills in your future career. So this is not the end of software engineering learning process. It's just a starting point. So this is the first thing that I want to say. Another thing is we have mentioned agile a lot of times across in this course. So you may also have heard of agile in like other conversations. So this lecture, we are going to have another look at this life cycle, look at what is agile, why we want to do agile, and how is agile in industry. Okay, so this is like we talk a bit about the life cycle in the first week, and then after we talk about all the stages, now we are going back to it. Like it's kind of a recap of all the stages today. Cool. So before we talk about Agile, I want to start with the waterfall model. So waterfall model is a more traditional way of developing software. So it follows the structure like a waterfall. So it's a linear process. So it starts with understanding the requirements in depth. It may take a couple of weeks, even a couple of months doing the user study, the market research and stuff. And then after the requirement engineering process, then they will go on like do the design. They will have a dedicated team for design that is not involved in the requirement engineering process and will also not involve much in the developing phase. They will be a dedicated team for design, and they will do all the conceptual modeling, all the modeling stuff. They will also design the interface, like how users interact with the system. And then after the design is the development process. Like the design team will hand over their design to the development team, and they will implement whatever the design team design. Like they will make sure that the UI that the design team given to development team works as expected. But developers also have no idea about what the stakeholders need. They only have the requirement documents and also the design document, but they will have no conversation with the actual stakeholders. And then after development, they will do the testing, and then deployment and maintenance. So it's a linear process. So this is very, very traditional. So then later on, people realize, well, following this waterfall model, it takes really long time to have an end product. And it's also very hard to go back to waterfall. Like you need to swim up, swim up the waterfall, which is almost impossible, right? And it's also very time consuming if you realize, well, one of the requirements was wrong. Like the requirement engineering team misunderstood the stakeholders' needs. And then you need to go back again to the requirement phase and then go down to development, testing, deployment, maintenance phase again. So you'll notice that this has a very huge problem here, that it takes a long time to, when there's some change, well, something was wrong during the process. So then, so this is the major problem with the waterfall approach. It's really hard to go back to the ladder again. It's also very time consuming to solve a problem. So, and also, another major problem is that there's no idea of whether it will work until the end, like after you deploy the system, right? So the requirement engineering team will think, well, this should work. I think this is perfect. This should solve the problem. However, when you give this to design team also have no idea about development. So they will design according to the requirement. But when it goes to the developers, then they may realize, well, this can be really hard or even impossible, or it's so very expensive, right? Like time consuming and stuff. So they have no idea about whether it works until the end. And if there's any mistake found on the later stage, for example, development or testing or deployment stage, it's also very expensive to fix because you need to go back to requirement phase again. So this is when and why there comes with this Agile model. So what do you think Agile model solve? What does Agile do? Yeah, so your understanding of Agile. Adaptable? Yeah, that's a very good description. So Agile model, so I really love this figure. So I show this figure every time. So when you want to design a car, right, the ways doesn't, you come up with a perfect wheel first, and the perfect chase, and the perfect body, and then the perfect top of the car. So this is not how the car is designed, like when we had no car at all, like there's no car in the world. So the way it works, we just start maybe a scooter, right, like just two wheels and a board, and then, but it works, right? Although it's not perfect, but it works. It allows people to travel from one place to the other place with a lot of walking. And then they come up with the bicycle, right? It's a lot faster and a lot safer than the scooter. And then there's the motorcycle. And then eventually is the car. So this is the idea of agile. So we start with something fast, although it's not perfect, but it's fast. And then we can get feedback. Well, the scooter is faster, but it's not that fast. Like we can have maybe a motor or something, some engine to make it faster, right? So it's more adaptive, and it should work from the beginning. Right, so this is I really love this figure. So this is agile. So when you look at agile model, you can see that it's not a closed loop. It's also not a linear waterfall, like very structured way of doing the software development. So it's a circle. It starts with maybe requirement, then design, and at any phase, when we go back to requirement, then we go back to the stakeholders again. So for example, during design, right? It doesn't mean that when the process moves to design, they can't go back to requirement. They can still go back to requirement. So for example, after they got the state diagram, they can still go back to the stakeholders and ask them, is this what you want? Do you have any other requirements? Is the scope defined? Is what you want for the system to be like, right? Again, like development, they can still go back to requirement even at the development phase. They may have a prototype like the scooter, right? It's not the perfect car, like drives really fast and it's super safe, but it's something working. And then they may go back to the stakeholders again. Like, what do you think of this? Right? Is there any challenge, any problem with the current version? What I can do? Right? And also testing. So testing may not only happen at the stage 4, like between development or deployment. So it may be at about in the middle of development or in the middle of deployment. So testing should also happen everywhere. We should always do testing to make sure that the software system works as intended, right? So you can see that Agile is really flexible. It doesn't follow the very linear structured way of developing a software. Okay, so this is, oopsie. Right, so the developer will always come back to the clients with the prototypes. So prototype is a working example of the intended implementation, but it's not the completed version, like the scooter. So prototypes can be at different level. So the simplest prototype maybe just you draw on the piece of paper that I mentioned in the previous lecture. So you draw a screen on a piece of paper, and here's the button, here's the function, and another paper at the next state. So that is a state machine, remember we just mentioned. So the first paper may be the first state, and the second paper is the second state, right? So you show, this is the very, very low fidelity prototype, but you can also use the softwares like Figma to draw a more high fidelity prototype, like the color with more details, and the stakeholder can even click on the buttons to transit from one stage to another stage, so they can have the full experience without actually coding anything. And the prototypes can be designed, developed very quickly, maybe just in one day or a couple of days, so that they can get very quick feedback. And then when the prototype is happily agreed with the stakeholders, they may also have an MVP. So Hayden will talk more about MVP in week 10 as one of the bonus lecture for 1531. But the idea of MVP is another version of the prototype, but you need to code something. The developers need to have a working example, like really working. The users can use that. An example of my MVP that I did with my team is, for example, we are developing an AI-based digital assistant. The end goal is to have our own large language model. We won't be using ChatGPT's API because of some privacy issues, because we don't want to send our data to ChatGPT again and again and again, right? So, however, developing our own large language model takes time. We don't want to spend a lot of time developing our own large language model and then at the end realize, well, this is not helpful. It's not doesn't bring enough value to the users. So what we did with this project is we start with using ChatGPT's API, which is really easy to use, really fast to develop the prototype, and then we bring this MVP. So it's a working example. It's a working prototype, right? So we call it MVP. So we bring this MVP to the users, and they use that, and they bring feedback. And then when we approve that this idea, this project works, then we start to develop our own large language model to bring a better experience for the users, right? It's like from the basic code to the motorcycles, right? So the whole structure works, but there's no engine in the basic code, right? But we bring in engine, we make it faster for our motorcycles. Yeah, so this is very, very agile, and it's also a very good practice in software development. So while I was taking thesis student, I found a very, very common mindset of our students is they want to start to have a perfect idea at the beginning, and they may start like building the front end and make it perfect, and developing the back end, make it perfect, and then designing the database and make it perfect. And it always take a very long time. And for example, they are designing the front end, make it perfect, and then when they're doing the back end, they may realize, something for the front end should be changed, right? So they go back to the beginning and change the coded perfect front end. So it's really time consuming. So what I normally suggest my thesis student while they are doing software engineering is start with something that works, like has the core feature of what you want to do. So for example, let's go back to the AI digital assistant example. My thesis student, they start with doing the authentication, like the auth, login, logout. They make it really good. But I asked them the question, is this your core feature of your digital assistant? No, it's not. Like it can exist, it can also not exist at the beginning for the prototype or the MVP, right? So what I told them is just have something that works. You may also use some platform called Streamlit or other platform that can help you build prototype or MVP really fast. It works, but it's not perfect. But you can get feedback really quickly, right? You know what needs to be improved, right? Really quickly, get feedback really quickly. Yeah, so this is a very important mindset of developing software, like doing things quickly, get feedback often. Yeah, so the core of Agile is a mindset. So so now we are using Agile almost everywhere. We say Agile methodology like Kanban, Scrum, but these are all like specific tools to use Agile. But Agile at its core is a mindset. It's not a tool, it's not a methodology, but a mindset. Like doing things quickly, get feedback often. Oh, another feature, another core thing about Agile is being collaborative. So the collaborative not only means that collaborate with your team member, but also collaborate with all the stakeholders. So for example, we are software developers. We want to be involved in the requirement engineering process to really understand what the users want. We should also collaborate with the design team to tell the designers, like, this is achievable, that is expensive, that it takes really long time to actually achieve or implement. Or we should also talk with the design team, ask the designer, well, why do you have the button here? Like, what kind of value do you want to bring here for the customer by designing the system in this way? So you have the idea of how the system should be, like how the software should bring value to the user. So collaborative is also another core idea in Agile. So developers shouldn't be just a closed group of people just doing the implementation. Developers ideally should be involved in the whole process of software engineering lifecycle. Right. So this is very hard to actually achieve in reality, especially in large companies. Like in large company, they have a very clear structure or hierarchy. Well, this is the design team, that is the development team. So this is very hard to achieve. So this is why in recent years, we have seen some startups like grow really fast because they implement things like, because their team is small, Like everyone is involved in everything, and they loop really fast. Like they get feedback really fast. So it's not an easy thing to achieve, especially in a large company. But they have been working very hard to actually implement Agile. Okay, so going beyond Agile. So with Agile, we mentioned that developers should be involved in all the process, should have communication with all the stakeholders, like the clients, the designers, and everybody on the team. However, there's still another burden, like between the development team and also the operations team and the infrastructure team. So the problem is on the left-hand side is the development team. So they develop something, it's ready for deployment. However, on the other side is the operations team, which their role is to deploy things and maintain the production version. However, they may say, well, the production environment is not ready. You should fix this first. However, the development team said, like, we have a lot of iterations with the clients, the stakeholders. We are really need to deploy this, get feedback from the real users. So they may argue, they may fight. So they asked you separate. So although the developers is in collaboration, is in Agile with the designers and the stakeholders. However, the operations team is still in solo. So this is where, like in 29, this is when where Flickr started to have 10 deploys per day. So they start to deploy minor small changes 10 times per day. Right, so this is a really life-changing thing for software engineering world. So what they do is they have the in this figure. So they break this wall. So they knock that wall off. They bring the operations team with this developer team and the whole team together. So they actually put everyone in the same team. Right. So they start to deploy things really fast. So nowadays, Netflix is also another very good example. So they deploy a lot more than this. I can't remember the exact number, but Netflix, nowadays they deploy things a lot more than this. So a lot of times each day. So the good thing is you deploy small things each time. So you can find problems or bugs really fast, rather than you have a very big problem and leave at the end, and when you deploy, you figure out there's a really big problem, and then you will again go back to the process and change things. It's very time consuming, it's also very expensive. So this is called DevOps. So DevOps really means, so DevOps we can think of it as an advanced version of Agile. So everybody in the company is the same team. It's very collaborative. Yeah. So the aim is to enhance the process of software delivery as a whole, like from requirement engineering to deployment. So you may always see this kind of infinite loop here. So they call it DevOps. So basically the idea is everybody on the same team. We are doing things iteratively. We are doing things fast, collaboratively. Yeah, so DevOps is also a mindset. It's also, again, not a tool, not a methodology. It recognizes that working in silo doesn't work. Development and operation engineers should work together and follow lean and agile principles and developing software in a rapid and continuous manner. Yeah, so you can see that a lot of companies nowadays have been using or following the DevOps mindsets. For example, AWS, Jira, Git, so they all follow the practice or mindset of DevOps. Yeah, Okay, so this is also another reason like why in 1531 we emphasize teamwork, collaboration so much, because it's such an important skill nowadays in software engineering world. Yeah, so another thing that we want to emphasize in 1531 for you to understand more about software engineering is like when we say software engineering, people outside of world will say, well, you do coding, right? So coding is the core of software development. So this is the old way of thinking of software development. So when we talk with industry review panels for the degree, what they emphasize, like what they hear in industry for software developers, they want people to know that software engineering is not just about coding. So there used to be a story like at the entrance of K17, the CSE building, they want to have a really large wall and paint on that coding or programming. But it was rejected by the software engineering people. Well, they say like CSE is not only about coding or programming, right? Like software developer should know coding, programming really well, but they should also have other skills. They should know the whole engineering life cycle. They should know agile, they should know teamwork, evaluation, and other skills as well. Okay, any questions so far? I know this lecture is quite general because the goal of this lecture is go back to the original, like the first lecture, to give an overview again of what you should have learned in 1531. So it's designed to be very general and high level. Yeah, any questions so far about software engineering in general? All good? Yeah. I hope you have learned a lot with 1531 and really understand what is software engineering. Okay, otherwise that's all for this lecture. It's a pretty short lecture. For next week we'll talk about iterations rate. So we'll spend a whole lecture talking about iterations rate. My suggestion is start working on iterations rate as soon as possible. Please do not wait for that lecture. So that lecture is designed and purpose is to answer your questions. So you should have started iterations rate and prepare some questions to that lecture. So that's how the lecture is designed to be. It's not an introduction to iterations rate. Okay, and then we'll talk a little bit more about auth, like authentication, although we have already talked about, we have already had authentication in the project, but we'll talk about coding, encoding, about a question about coding, encoding in this lecture as well. And we'll talk a little bit more about Git and software complexity. And then we'll also have another bonus lectures in week 10. The first one is about MVP and web front end. So this lecture will be delivered by Hayden. We added another bonus lecture for you. So this is another industry guest lecture. So it will talk about software project management tools. So for example, Jira, Confluence, and other tools. Right. Okay, that's all for today. Thank you so much. Thank you. Yeah, sure.
A few friends of mine are thinking of doing a project over the summer. It's going to be on like, what we've decided so far, like we're training an AI to get good at Connect 4, the game. Do you have any lecturers like that you know that could mentor us, or just like kind of validate what we're doing? Because we're just going to go off and do our own research, but it'd be good to have someone that can like review.
Oh, is it a hobby project or is it like a startup project or
Oh,
it's a research project?
just to learn, yeah, just as a hobby.
Oh,
Because I want to learn C++ and I also want to learn it, so we're just like, all right, we'll learn it over the summer and then we'll like do a good project.
Yeah. Agile. Being agile. Like being agile is so important.
Oh, okay.
Yeah.
You're talking about lecture, I don't know who that is. Okay.
Yeah. So resources. If you want to, it depends on what you want to learn, because developing a software project, if you want to learn more about how to make it make profit out of it, can be very,
We just wanna-
coding.
Yeah, we just want to code. Yeah, just as like because like I want to learn C++,
Yeah.
and the other guy knows C++ really well.
Okay, that's
But he
nice.
wants to do it because he wants to do AI.
Oh, okay.
So that yeah.
Yeah, for AI, like, do you mean want to use some APIs, or
Right now we've thought of using neural networks.
what kind of neural networks?
We don't know.
Ah,
That's why
okay.
like if there's a lecturer that's like that's their field, like AI is their field. If you know anyone, I mean if you yourself are into that.
Yeah,
but-
like I'm into large language model more specifically, so LLM. But general neural network, deep learning. I'm not sure what do you want. Like, do you want a mentor or do you want some resources?
Probably a mentor, yeah.
A mentor.
Yeah.
Ah, okay.
Because we're friends, so we're gonna see each other like every week. So we're gonna get the work done, but we would just like for someone to just review what we're doing. To
I'm
make
happy to do it.
Oh really?
Yeah, okay. Yeah.
Okay.
Yeah.
So would it be best to contact you with email?
Yeah, email or Teams both work.
Teams, okay.
Yeah, but I will be away for a couple of weeks during Christmas. Is
Oh,
that-
same for all of us.
Ah,
So
okay.
we're thinking, so I have my last exam on the 29th of November.
Uh-huh.
So the first few weeks we're just going to learn
Uh-huh.
the language.
Yeah.
And then in January we're probably going to like
Okay.
email you to just see if you
Sure.
can review our work.
No problem.
Okay.
Yeah, I'm happy to
So
do
like
that.
late January, like 15th of Jan.
Yeah.
Is that okay?
15th Jan. Yeah, I can do that.
All right. Thank you.
Oh, good. Thank you. Bye-bye.